thank you very much for the introduction. Thank you for the organizers for the invitation to join this wonderful new initiative. We'll see where it goes. I will talk about our first steps we're making. I think this has been scheduled quite well. In the next presentations, you will already see actual true results. We started the project a year and a half ago, and one of the things we are going to do is to work to AI OCR training to have recognition of cuneiform signs, automated recognition of cuneiform signs. But it's preparing actually my talk, or our talk we prepared, is really on the steps we are making towards having a training data set. It's a project which is funded by the Belgian government, science policy. So when we were writing the project, we were kind of thought we will do the OCR and we will find a partner in Belgium itself. But actually quite soon it popped up at a conference in 2022, a workshop in Leuven, where also Hubert Mara was, and also Timo Homburg was present. That they already had created a very good annotating tool. So we immediately made sure we had good contacts, and we continued those contacts. And I think it's already a very good example of having those networks and starting to work together with people who already came up with new initiatives. And so we found a good synergy there. It's part of a much wider story. As you can see, our project is called Cune-IIIF-orm, with in the middle IIIF. So the whole idea actually is when we have layered data, when we have annotated data, that we can all layer it into a IIIF environment. And as such, that we, by using the standards in IIIF, that we can compare it with other institutions which have similar kind of data, which is actually not really the fact yet. There is not that much cuneiform to be found and to be consulted at this moment via existing IIIF platforms, but as most of the institutions in the GLAM sector are using more and more IIIF, so also those who have content with cuneiform tablets, we kind of hope so in the further future more and more this type of data will also end up and will be disseminated via IIIF platforms. And so one of them, you can see there's a whole bunch of different things we're doing in this project. Gustav, who is also present here, will tomorrow give you a talk on our NLP choices and implementations and work we are doing. And so today I will talk about our first steps we're making in the supervised learning automatic sign detection. As you can see, as always, especially if you need funding, you have to show that everything is connected with each other. You have to come up with these kind of sufficiently complex workflows and processes to show that you really thought about it in advance. So if we zoom into actually the part we are going to talk about, we are working on here right now, what we did is that we are going to select some 200 old Babylonian tablets. We have them in the 2D plus format. All throughout the project, everything is being connected into a central data management repository. And each time we push the data there, it's being extracted for a specific task. And then it's being pushed back to that central data repository. And towards the end of the project, as it is funded by the Belgian government, everything has to be open access. So normally then it should be put open and accessible to everyone. What were the objectives we kind of set at the beginning of our project? As we all know, I guess most of us work in scientific projects. Not necessarily the objectives you set are really actually easy to meet by the end, but this is what we, in having some brainstorming, we kind of put it forward. That we would like to make sure that the machine learning OCR model we are creating should have a 50% success rate. We're working with old Babylonian texts, cursive written text, so quite difficult kind of material. That was part of the estimation to say we want a 50% success rate in a first big exercise we're putting out. And it should be successful on photorealistic images, because the general kind of idea is, yes, there are already quite a number of 3D images, 3D models of cuneiform tablets available. From our side, we have quite a lot of 2D plus models available, but actually the vast majority of the cuneiform tablets which have been imaged, they are flatbed scans, they are standard normal photographs in all kind of different conditions. Some of them are black and white, because they are older material which has been digitized in ongoing digitization programs. So that is kind of the things we had in mind when we put it forward, 50% success rate. And then as we are also working with several or data sets we're using, we're creating the input data of it, is with 2D plus images. We can kind of set a number of sub-objectives, which is also to understand if you in your data set, in the information you have, you also have information on the surface orientations. Actually, will it help to create a better OCR model or not? And then also compare which kind of visualizations are helping more, have an added value, do they have an added value? Is the added value worth to start working with that kind of data sets? Those kind of sub-objectives. What we had at the start of the project is that we already possess a whole bunch of cuneiform tablets which have been imaged with this multi-light reflectance system since 2004 or 5. That was the first projects we had with these multi-light reflectance systems, where cuneiform tablets is being lit from different angles, and based on that, an interactive, relightable model of your image surface can be processed. And we already have a number of thousands, I think 3,000-4,000 tablets we already have in our databases from different kind of collections across the world. And the whole project is focused on Old Babylonian text, because the central core set of material is actually the Old Babylonian collection at the Royal Museums of Art and History in Brussels. We kind of looked at our data set, at the number of texts we already have in our database, and we easily came up to something like 1,000 Old Babylonian texts which have already been imaged with that system. So as we are also very acquainted with how this all works, here you see a couple of videos for those who are not 100% familiar with this multi-light reflectance technology. What you have is that you have relightable photorealistic images, but also non-photorealistic images can be created with it. It uses three-dimensional information also, which is being extracted from your original data set. And as you can see, one and the same data set can be easily visualized in various manners. As I mentioned, our corpus we're actually working on is Old Babylonian. That is also because we're working together with University of Ghent, is one of the three partners, and there the assyriologist is specialized in Old Babylonian period, so it was an obvious choice to go for the Old Babylonian period. For the training corpus, then we selected two different image sets we had, one from Nippur, from the Hilprecht Sammlung in Jena, and from Dur Abieshu, from texts which were kept during when they were being imaged at Cornell University. And as you can see here, a random example of already an annotated tablet from this period. This cursive handwriting text with signs and lines which constantly overlap. Each time when a new sign has been intended after the other one, it actually already deforms the previous deformed one. So that is why we said the 50% rate, success rate would already be quite something, as we kind of understand that having automated systems to recognize cuneiform signs based on this type of cursive handwriting text might actually be extremely challenging. So then when we go to our data preparation, so we have these interactive data sets, but then actually to make the annotations, we try to find a way to have a standardized manner to work with it. So we have, for all the sides of each of the tablets, which is image, which actually hold cuneiform signs. Yeah? We didn't do it for the sites which have no cuneiform signs, obviously, to make sure we do not create data which will never going to be used. For all of them, we created actually 12 different visualizations of that image size based on that interactive image. First of all, 9 of them from different illumination angles, a very general illumination, which you see at the very beginning, which kind of also closest resembles in quite some circumstances the situation what you have when you have flatbed scans, where the illumination is not always perfect at all. And then more illuminations with raking lights, the kind of images which are easily produced when you do standard photography. And then based on the interactive 2D plus model, we can also generate automated line drawings. Those are the ones you're going to see right now. 2 different ones, and then also the one you see with that kind of blue appearance, that's a normal map. That's so a non-photorealistic representation of the data, and actually what you see there is that the different colors actually hold 3-dimensional information for each pixel that you can get, that you can extract that kind of information as well. So we created 12 different visualizations, and so at the beginning of the project, then you can start making calculations. So how many actually signs will we have annotated at the end of the project? So when we take 200 tablets, we kind of estimate that as not all of the sites will hold cuneiform signs, we'll have some 900 different signs. That gives us maybe 100 signs a tablet, but most probably it is more. Yeah? But of course, there are smaller tablets, there are bigger tablets, so we will only be able to make the count by the end of our annotation exercise. 2,000 unique signs, and then multiplied by 12 different visualizations. It might end up with something like 240,000 visualization, and actually, most probably, it will be a lot more. So then, we started working together with Timo Homburg, who was very, very, very eager, I think, also to see that somebody else is interested in using also the annotator. And his input was actually of absolute crucial to be successful. In autumn 2022, we really started more and more looking, okay, what is the process we need? And now since early 2023, and 3 weeks ago, we actually really started annotating. So the job is going on right now. So the transliterations, because most of the texts we are including here are already published, so we have the transliterations. So they are uploaded with the CDLI ATF. Or if we wouldn't have the transliteration, or transliterations need to be changed, that is something which can be done also in the cuneiform annotator. What we're doing actually, as you could already see, but we will see an animation immediately, we are cropping the signs. So it is being cropped by assyriologists. And for example, the Nippur temple tablets are being cropped by An Hoderis, which is exactly the one who has also published those texts. So somebody who was very, very well experienced exactly with the texts we're working on. And they're being cropped very close to that sign and that sign only. In a couple of annotation projects I saw, they use a rectangular or a squared annotation, so we are actually using polygons which can have multiple notch. Then you have to make a couple of decisions what to do, because actually a minimum of 3 different assyriologists will make the annotations. What about damages? What about very difficult to read signs, which are very hard actually to recognize. Are we going to include them? Are we not going to include them? So first of all, we said if there are reconstructions which are available, which are present in the transliteration, but actually not on the original tablet itself, obviously we will not annotate it. Yeah, that's a first. Yeah, and then we also decided to use one specific tag for all of the situations where it is broken, extremely vague, seriously fragmented, seriously damaged signs. We give them one tag. Whether we're going to use that in the OCR model, that's actually not still, we're not 100% sure whether it's useful. Yeah? But we tag it already because it's a very simple and easy, fast thing to do. But whether it's really going to be useful information to train our data set, that is not necessarily the case. It's each time also linked with the annotation is linked with the transliteration, so that IDs can be transferred. It is so the very difficult to annotate signs, we kind of said they will be ignored. Obviously, yeah, 3 different Assyriologists will have a different opinion on that. Yeah? Is this one very difficult or not? So this is something we have to take in mind, that of course not everybody does it exactly the same. But that will be true, of course, if you make the community even larger and even bigger, then of course that will be an issue as well. So we have it with 3 Assyriologists, but if more and more people would start doing the same exercise, it would end up with the same kind of situation. And then very interesting, so within the annotator, all of these 12 different visualizations of the same viewpoints are being uploaded. And so last week, also in preparation of this talk, I kind of asked to the 3 who are working on it, which images are you actually using to make the annotations? Yeah? And they all gave a different answer. Yeah? So that's also immediately very interesting, of course, to see. For example, Anne Hoderis, who has already worked for a very long time with the portable light dome results. She's already very familiar with the line drawing visualization. She favors that one. Other ones, which are way more familiar with working with photographs or with the real objects at hand, they more like the color representations. So that's also a very interesting thing to see, that once you have interactive data or multi-layered information that you can include different kind of visualizations, immediately, of course, that is also used by people from the astrological community. The basic idea is the thing I colored blue over there, is what do we actually want that the AI model gives back to the Assyriologists? So it is specifically the annotation we do. We want at the end that the AI model kind of gives us the IDs of the different signs, and that's it. Yeah? We still need, in our approach, we'll still need at this stage Assyriologists to interpret, of course, everything. We're not going already further with that. So here you see this annotation going on in the annotator. So we have different views which you can select of one and the same viewpoint on one and the same tablet. And then you can start, depending which visualization you like most, you can start annotating. When you made your annotation, a pop-up window comes where you can first of all mention which side of your tablet it is, what the transliteration is, so the ID it gets. You also mention which line it is, which character index it has on that line, and based on that information it is being recognized in the transliteration. That is what you just saw. And you save it, and you can bring up another visualization kind of to check out whether also in other visualizations this is exactly the close kind of crop you can make, or you can continue and go for the next sign. Then to pinpoint a few issues we already had is, for example, what about signs which are over the edges, yeah? Which definitely in Old Babylonian texts, but certain other periods have it all the time as well, is of course popping up all the time. As the whole idea is, it should work also when we use the algorithm to recognize signs on photographs. And of course, our photographs basically will mostly be from one side by one side by one side. So the theoretic 6 sides we have on a cuneiform tablet, that they will be annotated twice. Yeah? So we annotate them from, in this case, the obverse. They were annotated, but they are also annotated from, in this case, the right edge. Yeah? So we'll have a number of signs with actually 2 viewpoints where we have the same sign which is being annotated. A second issue we discussed was, okay, what about rotations? On a number of tablets, signs or lines are specifically have a complete different kind of rotation. So what about it? Are we going to tag it? Are we going to make sure that the model gets that information as well? We decided to do that, so Timo also provided that possibility. So here you have this esh sign, which is actually coming from the backside onto onto the right edge, which is being, you can see it over here also in an animation when it is being annotated. So here, then you see in the pop-up, again, same kind of situation, same kind of information is added with it, but here the sign rotation is 180 degrees. We do not go into 179 degrees, but more the kind of round numbers. We are not going to exaggerate. But in fact, here the same kind of situation as mentioned before. It is not 100% sure whether actually this kind of information will be crucial for the training model at all, because most probably the training model will actually take into account all kind of different rotations. Like whether a car is upside down or not, it will still be recognized as a car. So, but at least we have the information. It is tagged. If it is necessary to use it, we can use this kind of information. Here another example of a line which is continuing from the obverse over the right edge onto the reverse. When it is about compound signs, we decided to make sure, if it is a compound sign, that each sign which is building up the compound is being annotated separately. Yeah? That's all. Although maybe in the transliteration it might not have been transliterated as such, and that was also one of the reasons why it was really interesting to make sure that in the annotator, if the transliteration is automatically in full being uploaded in advance, that we can make changes into that transliteration, because sometimes it has been transliterated in the publication not as a compound and not separately with the different signs, but so that it can be changed over there. So here you have a few examples, especially in Old Babylonian texts with the sha-ten or sham sign, where you have it quite often. So that each of them are being annotated separately. A very specific issue is the one with Dinger 1. Where the Dinger is a literature really inside the 1. That was also a discussion we had last week to kind of finalize what we're really gonna set. First of all, it was like, no, Dinger 1, it's actually one, we should address it as one sign, but then of course it's not really correct, because in the transliteration it's always being recognized as a determinative. And secondly, we also see that in the stamps of that same name, really the Dinger is not incorporated with the 1, but really in front of it. So say they must have been very much aware of that it really was also had to be addressed as a determinative. So it is also being I don't know whether you can see my cursor. Can you see it? Yeah. Okay. So here we have this situation of a Dinger 1, where of course then on top of that, that is really the things we are now wondering as well. Will those automated models really recognize this extreme overlap of different signs over there in that area? Will it actually also recognize these very small kind of annotated situations? Here another one at the first line, where actually the determinative dinger an is actually doesn't look like an an at all, but actually as a me, which is which happens all the time in all Babylonian tablets. So then the export back to our central repository. So for each of the signs, those cropped areas, all of them will be extracted here. I made 2 examples just as an example what is actually happening. But for each of the signs, we will have 12 different visualizations specifically of that cropped area. It will follow a name-giving convention, of course, with basically in the naming of each of those visualizations, all the information included, which is also in the metadata and in the metadata fields which are being filled in by the SRLogist. And as you can see, actually, there's many more. The annotator that Timo developed can actually extract a lot more types and different types of metadata. Here we still have to make kind of final decisions. Actually, are we going to include everything, which is probably the wise choice, that at least all the data stays together, but again, whether all of that will truly be used for the OCR AI training, that's of course another thing. So towards the AI model then itself, I can be clear, this is something we will do from the summer 2023 onwards. So we haven't really done that yet. At this moment, you can see one of the things we will probably have to do is to compare single stage modeling with 2-stage detectors. We have a number of software and code programs which we kind of think we will go into use, but this is actually a work in progress. It is not for the upcoming weeks. Actually, up till I think June of this year, we will have a lot of work to annotate all of those tablets. The good thing here is, which is also always one of the things when you work with OCR, what is your learning trajectory? And here we have a supervised approach. But we have assyriologists who are willing to do it. We have funding to do the annotations. So as such, this is an approach we can follow, but the actual modeling itself still needs to be done further in the future. So maybe at Danish number 2, somewhere at the university where Hubert might be professor, who knows, we can come up with results. Thank you very much.